Okay, so when it comes to graphing speed and distance, they are fundamentally different. And what that means is um, distance distance and speed will always be on the y-axis. All right. So first off, you got to know what your y-axis is. Why is this not drawing? Well, the y-axis is pretty simple. It's you can make a y. Your x-axis will always be time. And why is this function not working? There we go. So, essentially with your y-axis, this will determine quite a bit. And understanding, ultimately what you want to do is make sure you are focusing immediately. Whenever you see any kind of graph, you want to look at this y-axis, especially for, distance versus speed, because they are not the same. There is a correlation there, the more speed, the more distance, but they don't mean the exact same thing. So understanding this will prove essential to your success here. So let's look at a few of these with distance. And today we're just going to focus on distance. If we look at what this is showing us, are we gaining any distance over time? And the answer is no. This is an object in fixed position. Therefore, we are not, this is no movement. All right, so it's also known as an object at rest. All right, pretty simple, but it will get complicated, especially whenever we have to go through the various types of graphs. All right, so here we see an equal amount of distance is being gained over time. All right, so what this means is this is showing constant speed. Constant speed means the speed does not change. It remains constant over any given period of time. Therefore, the distance that is covered is the same distance. I mean, if you think about it, if you're traveling somewhere that's 60 miles away and you go 60 miles an hour the whole time, it will take you an hour to get there. That's if you travel at a constant speed. It's kind of hard to imagine that because we do run into traffic and everything. But, imagine airplane travel, like flying in an airplane, less traffic, you can maintain a speed. That's why, for the most part, airline companies are very accurate with arrival times and departure times. Of course, then there is weather that can influence that, but we won't worry about that right now. All right, so here we're comparing the distance of two runners, all right? The dotted line is one runner, and the non-dotted line, I should say, is another runner. So let's think about this. Who came in first and why? And this is where, understanding the rules of a race. Like you win a race by, is it doing it in more time or less time? Less time, because that's the point. You want to do it as quick as possible, therefore you win the race. So this is where not only, it's like which one of these actually show a runner doing it in less time. And this is where you have to focus on, come on, get off of there. You have to focus on the x-axis, which will most likely always be time. If we look up, the dotted line ran the same distance in less time, therefore covered the same amount of distance in less time, therefore they win. Trust me, I understand this stuff can be quite non-appealing in other words, boring. But it's actually easy to understand, but it's also extremely easy not to understand if you don't pay attention to these ideas. So the thing is, yes, because the dotted line actually traveled or won the race in less time, that means they traveled at a higher speed. There's the correlation, how the distance and speed actually link together. But still not the same thing. Both speeds are constant. We know this because we see no dips in the line. And this is where it really, really comes into play whenever we go down to the next graph, which is acceleration or accelerating, gaining speed. So if we look here, you know, our line is doing one of these, where if we actually were to dissect this a bit, you know, we have a constant speed here, but then all of a sudden we gain a lot more distance in less time, which indicates acceleration, a gaining of speed, increase in speed. What you also find with this unit is, you know, typically we think of accelerating as getting faster, but, you know, acceleration in scientific terms just means a change in position, which sounds really confusing, and it can be, but it's one of those things you got to learn. So if we're looking at this this graph right here below, what we find is, you know, based upon which line you're looking at, you know, here's a fast, steady speed because we're covering a lot of distance in less time. Here's another constant speed right here. But then we notice that, wow, we're not gaining any distance. So therefore they're stationary or at rest. Now this is where it gets kind of confusing, and I don't really worry about this part very much. It says returning to the start. What I would do is not worry about that. All right, that's kind of ridiculous. But if we look at our final line, we see that curvature, which is indicating gaining speed. And it's really easy, you know, if we were to contrast, you know, constant speed versus gaining speed, you have that slope there. And you know, it all starts with focusing on your y-axis, all right? Something of note, your y-axis, you can actually make a y standing up. X-axis, I mean, we don't, I mean, essentially what it comes down to is understanding your y is vertical, and you can make a y out of it. And it's simple things like that that go a long way with understanding this. Tomorrow we'll tackle speed graphs, and this is where we really start to differentiate between the two, and understanding that distance and speed are not the same thing, even though there is a correlation, a link of information there that does coincide with one another.